Okay, so this is what is a thermistor, basically first. We're going to use a thermistor to measure the temperature on our satellite or on our CanSat. So a thermistor is what's known as a semiconductor, okay? And a semiconductor is a material, the word semiconductor might help, it's a material that is not a good conductor and it is not a good insulator, it's somewhere in between the two. Okay, now a good conductor is something like a metal, and in a metal, the way the bonds of a metal are organized, there are a lot of electrons that are allowed to they're almost free to move within the metal. Okay, and when we place a positive charge on one end of the metal and a negative charge on the other, the electrons which are negatively charged will move towards the positive. Okay, they're attracted. Now that allows for a current, obviously, that's a current flowing. So a metal is a good conductor. Now, for a semiconductor at room temperature has very few electrons available to do that. So when you apply a plus and a minus to either end of a thermistor, you will get very few electrons and therefore very low current, if any, flowing. So that kind of means the resistance is high, because remember Ohm's law, V equals I, or the resistance of something is defined, divide by I, as V over I. So if the current is small, the resistance is large. If you make the denominator of a fraction small, you make the resistance large. So since there's a very small current in a semiconductor, it has a very high resistance. Okay? But what you find with a semiconductor is if you heat the semiconductor, the electrons that are trapped in covalent bonds become free. They get enough energy to break free from the bonds. And what happens is the hotter it gets, the more electrons that break free. And these electrons are now available for conduction. That means that as you heat a semiconductor, it becomes more like a metal. It becomes a good conductor. Or as you heat a semiconductor, the current increases, which therefore means its resistance goes down. So as temperature goes up, as temperature increases, the resistance of the semiconductor decreases. And what you find is then a semiconductor is a way to tell you what the temperature is, okay? And in particular, by looking at the resistance of a semiconductor, you can predict what the temperature is. So what happens is we have a particular type of a semiconductor called a thermistor, okay? And for a particular thermistor, we can measure its resistance. So a thermistor might look something like this. These are wires coming out of it. And we could put an ohm meter across it. And then what we can do is we can heat this thermistor gradually. Now, a way of doing that would be to put the thermistor into a test tube of water or another substance that is an even better conductor of heat. And what you do is you also put in a thermometer. So if you've got a thermometer and a thermistor, and you're measuring the resistance using an ohm meter, you can get results for the thermistor for temperature of the thermistor and resistance. And when you get a variety of sets of results for temperature and resistance, you might start with ice in the water. So you start at 0 degrees, and as the ice melts, you can then start to heat the temperature with a Bunsen, or to heat the test tube with a Bunsen burner. Then you're gradually heating the water in here and the temperature of the thermistor is rising. So you can take readings perhaps every 5 or 10 degrees to see how the temperature and the resistance compare. And then what you do is what we're always telling you in maths, that we can use maths for. You will plot a graph of the resistance of the thermistor as the temperature changes. Okay? Temperature in degrees Celsius maybe. And you will find that the resistance of the thermistor decreases as the temperature changes. Okay? Now, that's how thermistors can be used to tell the temperature. Because once you've plotted this graph and you know a particular value of resistance, that if the thermistor's resistance is this value, you can then use your graph to read off the temperature that's associated with that resistance. Okay, so hopefully that's explained a little bit about how a thermistor works. And when you purchase a thermistor, the thermistor will come with a data sheet, and that data sheet will contain exactly the correct graph for that thermistor. And it will tell you the temperature for any particular value of resistance. Or you can read it as, it will give you the resistance for any particular value of temperature for that particular thermistor that you are using. So our thermistor that we're going to use will be like that. So I'm going to explain how we're going to use that in our circuit.